This is an IIPMT 2014 question in collisions work for energy. The problem is like this. A body of mass 4m is lying in a xy plane at rest. Suddenly exploded into three pieces. Two pieces each of mass moves perpendicular to each other with equal speed v. What is the total kinetic energy generated in the explosion, right? Let's try to understand what he's trying to say. There is a mass of 4m who is initially in the state of rest. So what we can say? Kinetic energy initially is half 4m. Initial velocity is 0. So initial kinetic energy is 0. Final kinetic energy itself is the energy generated in the process. But it is said that this 4m is divided into three pieces. One m with a speed v moves like this along the x direction. Another m moves perpendicular with the same velocity. Out of the three pieces, two pieces moves perpendicular to each other. How does the third piece move? That we have to find out. We can say in explosion or collision, when no external force acting is there, momentum is conserved. Momentum initially is 4m into 0 because it is initially in the state of rest. It is divided into three parts further. P1 bar, because directions are there, let me take vectors P3 bar. So P3 bar equal to minus of P1 bar plus P2 bar. This is P1, M1, V1. If I have to say P1 bar, it's along I cap because it's x-axis. This is P2. If I have to say P2 bar, I have to say J because it is y-axis. So minus of P1 means MV I cap. P2 means MV J cap. But if you want to find their magnitude of that momentum, root of x component square plus y component square plus z component square. This is root 2 times of mv. So this, if I have to draw the resultant of that P1 and P2, it will be somewhere in between them. P1 bar plus P2 bar is root 2 times of mv like this. P3 is opposite of P1 plus P2 bar. So because P1 plus P2 are this way, it is obvious that P3 has to be this way. This is P3, equal in magnitude, but opposite in direction. How much is that P3? Out of 4m, m and m were gone here, remaining 2m are there, must be having some velocity x. So I can equate the conservation of momentum and P3 equal to, as I told you, 2m into velocity x. So how much is the x velocity? Or let me call it like V3, just for convenience. So 2m into V3 equal to root 2 times of mv. M and m can be cancelled. That implies V3 equal to root 2v by 2. That is v by root 2. I got the final velocity. So I can calculate the final kinetic energy. Kinetic energy final is kinetic energy of 1, 2 and 3 finally. Kinetic energy 1 is half mv square. Kinetic energy 2 is another half mv square. Kinetic energy 3 is half 2m. From where this 2m is coming? This 4m is split as m, and 2m in the perpendicular direction of x and y. And this is v3 square, third base. So half mv square plus half mv square plus half mass is 2m. v3 square means v by root 2 whole square. So how much is this? Half mv square for the second body, half 2mv square by root 2 whole square is 2. This 2 and this 2 will cancel. So this will be half mv square plus half mv square plus half mv square 3 times. So that's nothing but 3 by 2 mv square. That's the total energy generated in the explosion, and that's even the energy that is gained in the explosion because initial kinetic energy equal to 0. That's how we solve this problem. So while solving this problem, we have followed some important things that mm, momentum is conserved in a collision, and kinetic, basing on that I have calculated the velocity of the third piece. Of course, I found its direction also. If required, we can find it. Basing on that, I have calculated the total kinetic energy. That's how we solve this problem. Thank you for watching.